Hello everyone and welcome once again to yet another masterclass. And I'm your host, your dost, and as usual in the ghost mode, Mohit Jain. And I welcome once again you all to my channel MJ Maths and Stats. That's MJ Magic Studio to you. On this hope that you would have subscribed to the channel. If not, please do it right now. And we would be talking about the last digit of any expression, how to find it, and what are the nuisances and different kind of question which can be asked pertaining to last digit, that is unit digit of any expression. So without wasting any further time, let's start now. So all set, let's start now. Unit digit or end digit or last digit of any expression. First of all, let us deal with some linear concepts. That if I say, if you add 25 with 42, what would be the last digit? 25 plus 42 is 67. We'll say that last digit of this addition is 7. It is simply adding the last digit of 25, that is 5, with last digit of 42, that is 2, and 5 plus 2 will give us 7. This is what we mean by finding the last digit. Whatever expression is given, we need to find the last digit. Like similarly, if it is 225 plus 422, in that case also, last digit would be 5 plus 2, that is 7. Whatever is the value of the entire expression, we are not looking out for that. We are just considering the last digit of the expression. So to find the last digit of the expression, we just need to find the last digit of the numbers and then do the operation whatever is asked. Now if I ask you, find last digit of 3293 plus 4296 minus 3283 minus 7299. Give it a try and tell me what should be the last digit of this expression without actually solving the entire expression. Now if we just look at the last digit, we will find that we have got 3, 6, 3 and 9. So last digit of the entire expression should be 3 plus 6 minus 3 minus 9. That will give us minus 3. Now, we just need to understand that last digit cannot be negative. If after operation it is coming at negative, then what to do? If result is negative, add the base points to it. Base point means the number system in which we are playing. Here we are talking about decimal number system. So, since our decimal base point is 10, the last digit finally would be minus 3 plus 10, that is 7. If you still remember how you used to do subtraction, if we are like 137 minus 89, if we are doing, we used to carry 1 from the number 3, that becomes 2, and now 7 becomes 17. We are carrying 1 means we are taking the base points from the neighbor. Base points are 10 in this case, that's why 7 becomes 17. Now 17 minus 9. 17 minus 9 would be 8. Similarly, you can also check like this. 7 minus 9 would be minus 2. Actually, you are adding the taken carryover base points to it. That's why it's become 8. Likewise, if after doing all the linear calculations, you are ending up at a negative point, please add up the base point of that system. Base point of our system is 10. We are adding up 10. So last digit of this expression would be 7 and not minus 3. Now let's take another example. Find last digit of 93 into 96 into 83 into 99. Simple again. Just work out with the last digit of these expression and do the mathematical operator whatever is required. So we need 3 into 6 into 3 into 9. The last digit of this multiplication would be last digit of the entire expression. So 3 into 6 will give 8, 8 into 3 will give 4, 4 into 9 will give 6. So last digit of the entire expression would be 6. So what we need to remember is, while multiplying, if any number ends with 0, if we are doing multiplication and if any number ends with 0, obviously the entire product will end with 0. Then automatically the last digit will become 0. And again, if in a series of multiplication, you need to check whether even number and a multiple of 5 is there or not. If both even number and multiple of 5 is there, then obviously also at that time, the multiplication will end with 0, isn't it? So if we are looking out for last digit of 73 into 74 into 75 till 99, and we see that there is 80 here, in between there is 80, this expression is automatically obviously ending with 0, but still till this point also, if it is given, we have an even number and we have a number which ends with 5 or divisible by 5 or ends with 5. In that case also, our last digit will be 0. So even and 5 is present, that's why last digit would be 0. This is all about linear concept. Generally, questions are not asked related to linear concept. It is just a basic introduction. We'll move further on it. Now, actual question related to unit digits are asked from exponential concept. We may start with an example like find last digit of 23897 to the power 43925. Now this is known as exponent concept. Suppose A is equals to 23897 to the power 43925. Now we are concerned with only the last digit of the base, that is 7, let it be L, and the power, that is exponent, suppose that is A. So actually it is something like this. Last digit of the entire expression is nothing but same as last digit of L to the power A. So we would be only concentrating on the last digit of the base number and the entire power. Now, depending on this, now tell me what can be the L of any number. Last digit of any base can be from 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. We need to deal with these 10 digits at L, and then we will see with changing value of A how we can find the last digit of the entire expression. So suppose these are L, last digit, and power, that is A, last digit of any number. We just try to fill up this particular grid. 1 to the power 1 last digit, and this is the last digit table. 1 to the power 1 last digit is 1. 1 raised to any power, last digit would be always 1. Now 2 to the power 1 is 2. 2 into 2 last digit 4. 4 into 2 is 8. 8 into 2 is 16, last digit would be 6. 6 into 2 is 12, last digit is 2. 2 into 2 is again 4. Then for 3, 3 to the power 1, 3, 3, 3, 9, 9, 3, 27, 7, 7 into 3, 21, 1, 1 into 3 is 3, and 3 into 3 is 9 again. 4, 4 into 4, 16, 6 into 4, 24, again 16, again 4, and again 6 we will get. 5, whatever be the power, it will always ends with 5. 6, 6, 36, 6, 6, 36, it will always end with 6. For 7, 7, 7 into 7, 49, 9 into 7, 363, 3 into 7, 21, 1, 1 into 7 is 7 again, and then 9. For 8, 8, 8, 4, 4 into 8, 32, 2, 2, 8, 16, 6, 6, 8 is 48, 8, and 8 into 8, 4 again. 9, 9, 9, 1, 1, 9, 9, 9 to 9 will give you 1, 81 ones, and then 9 and 1. Now, this is the last digit table. And if we look at it carefully, we can see that after every 4 power, the column for the fifth power, is same as column for the first power. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9. In the fifth power, the entire first power column is repeating. That means after every 4 power, the last digit for any last digit of an expression for any last digit repeat itself. That's why we follow cycle of 4 while calculating the actual value of A. Okay, in this thing, we can bifurcate this into 3 parts. First, let us look at type 1. If L is 0, 1, 5 or 6, look at 1, look at 5, look at 6, and we know that for 0, the last digit would be 0. L to the power A, last digit of L to the power A is also 0, 1, 5 or 6. If any number ends with 0, 1, 5 or 6, any power on it, the last digit of that entire expression will also end with 0, 1, 5 or 6. Type 2, second type of number you can see, last digit 4. If last digit is 4, we go with odd power and even power. If power is odd, last digit of the entire expression will be 4. And if power is even, last digit of the entire expression would be 6. Same goes with 9. If L is 9 and power is odd or even, if it is odd, the last digit of the entire expression is 9. And if it is even, last digit of the entire expression is 1. Now in group 3, we have the remaining L's. What are those remaining L's? 2, 3, 7 and 8. And for this, we will follow cycle of 4, and how we will see next. So we'll go slow once again with group 3 L's. If L is 2, 3, 7 or 8, then we use cycle of 4. Now how to use this cycle of 4? Step number 1, divide last 2 digits of your exponent A by 4. Divide the last 2 digits of A by 4 and find remainder. Second point, if remainder is this, your new A, your new value of exponent will be what? If remainder is 0, the new value of exponent will be 4. If remainder is 1, the new value of exponent would be 1. In case if remainder is 2, new value will become 2. And if in case remainder is 3, new value will become 3. It is just that after every 4 powers, the power 1 is repeating itself. That's why we are dividing the entire number, the entire power, the entire exponent, that is A, by 4. And how to divide a number by 4 is to check the last 2 digits of the number. If last 2 digits of the number is divided by 4, whatever be the remainder, it will be the same remainder if the entire number is divided by 4. So if remainder is 1, our new power will become 1. If remainder is 2, new power will become 2. If remainder is 3, new power will become 3. But mind it, in case the remainder is 0, that means it is breaking up on the 4th position on the table, because that number is fully divisible by 4. Then we will not put the new value of A as 0. That is the big mistake. Please don't do it. Instead of that, the new value of A would be 4. Thus, we can say that last digit of A is nothing but last digit of L to the power A is nothing but last digit of L to the power A dash. This is our final objective. If we can calculate this, this will be same as last digit of the given expression. So it's execution time now. Whatever we have seen, the process which we have seen, we need to put them in practice. And everywhere we are supposed to find the last digit or the unit digit of the expression. What should be the unit digit of 122 to the power 173? Step by step. Step 1. What is L? L is 2. What is last two digits of A? That is 73. That's it. Now 2 comes in group 3. That means it will go with cyclicity of 4. That means we need to divide the power by 4. If we divide 73 by 4, remainder is 1. That means we are looking out for the value of 2 to the power 1. The last digit of 2 to the power 1. Last digit of 2 to the power 1 is 2. That means last digit of this entire number is nothing but 2. I hope you are getting the groove now. Now let's try to solve the next example. 2153 to the power 167. It won't take much time. Do it. Okay, let's see now. Last digit of the entire expression is 3 and last two digits are 67. That means we are looking out for last digit of 3 to the power 67. Now 3 comes in group 3. That means we need to divide 67 by 4. 67, 64, remainder would be 3. We are looking out for the value of 3 to the power 3. 313, 329, 9 into 3, 27. That means last digit of this entire expression is 7. Just do it with help of arrow diagram. Find L, last two digits of A. Divide A by 4 if it is a group 3 and then find the value. Let's do one more. 2137 to the power 754. So again, L is 7 and last two digits are 54. We are looking out for 7 to the power 54. 7 is in group 3. We need to divide 54 by 4. When we divide 54 by 4, 52 remainder is 2. 7 is square is 49. That means last digit of the entire expression is 9. Okay, so we can see L here is 4, which is type 2. That means odd even. So we have 4 to the power even plus 4 to the power odd. 4 to the power even last digit is 6 and 4 to the power odd last digit is 4. Now 6 plus 4 gives us 10. So last digit would be 0. Very good. I hope you people are working along with me. Let's take one more example. 2464 to the power 1793 into 615 to the power 317 into 131 to the power 491. What it should be? 4 to the power odd. 4 to the power odd is 4 into 5 to any power, 5 to the power anyone, this belongs to group 1, will end with 5. 1 to any power, it belongs to group 1, it will be again 1. 4 into 5, 20, it is giving 0 at the end digit. We can also see that since it is 4 an even number, multiplied with 5, and here it is 1, obviously the multiplication should end with 0. Let's take one more. Find the last digit of 3 to the power 40. Quickly, give me the answer. Now it is 3, it belongs to type 3. 40 divided by 4, remainder is 0. And what was we have discussed in algorithm? If remainder is 0. If remainder is 0, please don't write 0 as the new value of A. It should be 4. If remainder is 0, it ends on the cyclicity of 4. It is 3 to the power 4, 9 square, 1. It should end with 1. Last digit of 3 to the power 40 is 1. Please don't write 1 because 3 to the power 0 is 1. It is ending with 1 because 3 to the power 4 ends with 1. Okay, let's do the next one. Give yourself some time and do find the answer first. Okay, so I believe that you have the answer by now. 1 to power anything ends with 1. 1 to power anything ends with 1 minus 6 to power anything, these all are type 1, will end with 6. 5 to power anything will end with 5. Again 6 to power anything will end with 6, and this is with no exponent. Exponent here is 1. 259 to the power 1 will end with 9 plus 9. So what we have, 5, 6, 6 gone with 6. 9 plus 1 is 10 minus 6 is 4. So last digit of this entire expression is 4. Let's keep on taking examples. Number 8. Find the last digit of 1007 to the power 2008 plus 1002. Tell me. 7 moves into type 3. 08 when divided by 4 leaves remainder 0. That means we are looking out for 7 to the power 4 last digit, and with that we will be adding up 2. So 7 to the power 4 is 9 square, that is 1. So 1 plus 2 is 3. Last digit of the entire expression is 3. Bingo. Let's do a few more quickly. 4387 to the power 245. More you practice, more confident you would be. Into 622 to the power 72. Give me the last digit. Okay, so what should be the answer? 7 in type 3, 45 we need to divide by 4, then remainder would be 1. So it is 7 to the power 1 into 272 when divided by 4. Bingo, it is divisible by 4. Yes, that means we are left with new power 4. So 7 to the power 1 would end with 7, and 2 to the power 4 is 2, 4, 8, 6. 6 into 7 will give 42. So last digit of the entire expression would be 2. Bingo. One more before we move into different types of questions. Let's quickly give me the value of last digit of 343 to the power 125 minus 625 to the power 280. Okay, so quickly type 3, 25 divided by 4 will leave remainder 1. We are looking out for last digit of 3 to the power 1, that is 3. Then we have 5, any power, this is in type 1. Any power on 5 will end with 5. So we have 3 minus 5, that is minus 2. Since it is negative, we'll add the number system base point, that is 10. So last digit would be 8. Please don't say it is minus 2. Now you move on to the new different kind of question. Let's do it. Okay, find last digit of 43 to the power 44 to the power 42. Give it a try. Now we will be following the same algorithm that we have. This entire is our A. A is entirely 44 to the power 42. And we need to check what will be the remainder when this is divided by 4. We can see that 44 itself is divisible by 4. That means 44 to the power 42 is fully divisible by 4. That means when this power A is divided by 4, it will leave remainder 0. And then the new value of A will become 4. So now what is our L? L is 3. This is type 3 number. So we are looking out for simply 3 to the power 4 last digit. 3 to the power 4 last digit is 1. So last digit of this entire number, 43 to the power 44 to the power 42, is 1. Let's take up one more example to make it more clear. Find the last digit of 47 to the power 41 to the power 42. Give it a try. Okay, again 41 to the power 42 is our A. A is 41 to the power 42. What is the remainder when 41 is divided by 4? Remainder is 1. Then the remainder when this entire number is divided by 4 is actually 1 to the power 42. That is 1 again. So when 41 to the power 42 is divided by 4, remainder is 1. Now 7 belongs to type 3. We are looking out for large digit of 7 to the power 1. That is 7. Let's take one more to make this thing more clear. Find the large digit of 32 to the power 32 to the power 32. Once again I am repeating the entire process. This is our A. 32 to the power 32 is A, which need to be divided by 4. For that, just check the base number 32. 32 when divided by 4 leaves remainder 0. That means 32 is divisible by 4. That means the entire 32 to the power 32 is divisible by 4. It will leave remainder 0. If it leaves remainder 0, new value of A will become 4. Now 2 falls in type 3. So we are looking out for large digit of 2 to the power 4. And large digit of 2 to the power 4, 16, that is 6. So large digit of the entire number, 32 to the power 32 to the power 32 is 6. Okay, one more. Large digit of 12 to the power 13 to the power 14. Once again, the entire number, 13 first, need to be divided by 4. Remainder is 1. Now 1 to the power 14 is 1. That means the remainder of this entire A when divided by 4 is 1. 2 belongs to type 3. Last digit of this is nothing but 2 to the power 1, that is 2. The last digit of entire number 12 to the power 13 to the power 14 is 2. Now hopefully, since you must have understood, let's try this. Find the large digit or unit digit of 12 to the power 14 to the power 15. Pause, take up your time, and then look out for the solution. So I hope you have the large digit of this expression by now. This is our A. Let's concentrate. A is 14 to the power 15. We need to divide this number by 4 and we need to find the remainder. Now 14 can be written as 4 into 3 plus 2 to the power 15. And when expanded and divided by 4, all the terms would be divisible by 4 except the last term, which will be 2 to the power 15. Now, when 2 to the power 15, clear? 2 to the power 15, isn't it, this is divisible by 4 again, because it is only 2 is square. So the last digit of this entire expression, the last expression of this entire binomial expression, the last term is 2 to the power 15. And all other terms will contain 4 or powers of 4 that automatically would be divisible by 4. Now the last term of this expression would be 2 to the power 15, which is obviously divisible by 4. That means the entire number 14 to the power 15 is divisible by 4. It will leave remainder 0. Remainder 0 means new value of A is 4. Now 2 is in term 3, type 3. We are looking out for last digit of 2 to the power 4, that is 16. So last digit is 6 for the entire expression. I hope this is making sense now. On this note, let us do one more. Number 16. Find the last digit of 12 to the power 13 to the power 14 to the power 15 to the power 16. Give it a try. Again, we need to concentrate on 13 first. 13 when divided by 4 leaves remainder 1. And 1 to any power will leave 1 as the last digit. 1 to any power will leave 1. That means the remainder when 13 to the power 14, 15, 16 power is divided by 4, remainder is 1. 2 belongs to type 3. So last digit of the entire expression would be 2 to the power 1. And that will end with 2. Bingo. Now we'll move on to the different set of questions. So the next question is on your screen. It happens to be there in CAT examination 2005. Read it, give it a try. Pause the session and give it a try first. So what is the last non-zero digit of the number? Zeros are all because of this 0. So actually 30 is 3 into 10 to the power 2720 and also to the power 2720. So zeros are all because of this 10 to the power 2720. Non-zero digit will be all because of the last digit of 3 to the power 2720. Bingo. This is in type 3. We need to divide the last two digits by 4. 20 is divisible by 4. That means remainder is 0. If remainder is 0, value of new a will be 4. So last digit of 3 to the power 2720 is 3 to the power 4. 981. Last digit is 1. That means last non-zero digit of this number while expanded is 1. Give it a try. So I believe that you have answer by now. Okay, first of all, 3 to the power 32, last digit of 3 to the power 32, 3 is in part 3, type 3, 32 divided by 4, remainder would be 0, new power will become 4. Is 3 to the power 4, last digit is 1. Now the thing is, any number having 1 as the unit digit will always give 2 at the unit place when divided by 50. Like suppose we are dividing 11 by 50. We can just check 0.0, then it will go 2 times 100, then again 2. You will see that unit digit of this solution is always 2. If a number ending with 1 is divided by 50, then the unit digit after the decimal points, the unit digit will be always 2. In this case, y will be always 2. Y will be always 2. Value of y will be 2. Give it a try. First of all, what are these two numbers? If I treat 3 to the power 2003 as a, then I can see we have got a minus 1 and we have got a plus 1. That means these are two consecutive either odd numbers or these are two consecutive even numbers. It all depends on the value of a. Now a is 3 to the power 2003. 3 is an odd number. Odd number raised to any power will always end up giving us an odd number. That means since a is odd, a number less than a is even and the number greater than a is also even. That means this expression capital A and this expression capital B both are even numbers. And the second beautiful thing is both are consecutive even numbers. You can see a minus 1 and a plus 1 are consecutive even numbers. Now the theory of LCM in case of two consecutive even number goes like this. For this you may go through the link given in the description where we have the master class of SCF and LCM. The link is there in the description. Please go through it. What does it say? That if we have two consecutive even number, LCM of two consecutive even number is given by half into product of these two numbers. So LCM of our two number is half into a minus 1 into a plus 1, that is a square minus 1. That will be 3 to the power 4006 minus 1. Now we need to find the last digit of 3 to the power 4006. 3 to the power 06 when divided by 4 will leave remainder 2. 3 to the power 2 is 9. That means last digit of this expression 3 to the power 4006 is 9. This is the number. When 1 is subtracted from it, the last digit of this number would be 8. And when it is divided by 2, it will give last digit 4. Now it is always in a doubtful situation that what was the second last digit of this expression. Depending on the second last digit of this expression, we can say that either it would be 4 or 9. For second last digit, how to find second last digit and to confirm that whether it would be 4 or 9, do connect us to the second part of this master class where we will do second last digits also. And so master class se jate jate few properties which would be of help if we are solving that particular kind of question. And it says that any odd digit, if L is odd, raised to the power 4n, last digit will be always 1 except for 5. Because last digit for 5 to any power ends with 5. Or any other odd digit, if power is 4n, last digit has to be 1. And if your L is even and power is 4n or divisible by 4, then last digit will be always 6 except for zeros. And for to check this, please do the checking yourself. And one more property which would be of great help to you is 1 to the power 4n plus 2 to the power 4n plus 3 to the power 4n till 10 to the power 4n. This expression's last digit is always 3. Try it yourself how it is. So on this note, I'll see you soon. This is Mohit Jain signing off from MJ's Maths and Stats at the MJ Magic Studio to you on this note that I'll see you soon. Plus, please don't forget to like, comment and subscribe. Thank you everyone.